Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help you out with everybody's favorite topic, word problems. Alright, we're going to start with the first one in the handout, and I just kind of shorthand what it said here. We are looking for two numbers. It says find two numbers whose sum is 50 and whose product is a maximum. So we're looking for two numbers. They add to 50. Their product is a maximum. Again, hopefully you have your sheet sitting right in front of you. So first, let's talk about this add to 50. Actually, before we do anything, we should actually define a variable. So we're going to say, how about let x equal one of the numbers. One of the numbers. Now, if these numbers add to 50, if x is the first one, the other one's got to be 50 minus x. Now, if you don't see that right away, let's say I said the first number was x and the second number was y, but they have to add to 50. And you notice if you solve that for y, you get 50 minus x. So I think we should do it this way so that we only have one unknown. So let's clear that. All right, next. Their product needs to be a maximum. So I'm going to say, let's say p of x, that's a function. And I'm just using p to stand for product, would be, just like it says, the product of the two, x times 50 minus x. All right. Now, I'm going to take this guy here and mess around with it a little bit. We can write this 50x minus x squared. Okay. Now remember that this is parabolic because of the 2 here, and remember standard form for parabolic. I'm going to write that over here. Looks like this. So we want to make this look like this. So let's rearrange this a little bit. Minus x squared plus 50x. Let's factor this minus sign away from these two terms. Leave a little space. Oh boy, this one, I think I'm going to get a calculator out for this one. Okay. Now, to complete the square, remember we look here, cut that value in half, that'd be 25, square it. Okay, that's 625. So let's put a 625 here. Now we have to maintain equality. And you notice I put a 625 here. There's a minus sign in front of it. So what I did is added negative 625. So over here to the outside, let's put a plus 625. This now by design is x minus 25, the quantity squared. And again, plus 625. All right, so that means that if we were to plot this graph, I'll just do a real quick sketch here, like product again against x. Well, for starters, you notice it goes through 0. It goes through 0, 0, and 50. The vertex is the point 25, 625. I'll just put that here. It's got another 0 at x equals 50. So this function is looking something like this. The maximum value is here at the vertex. All right, so that maximum product is 625, and that first number is this value, 25. So x must be 25. There's our first number, because that is the value of x that gives us the maximum product, and that maximum product is 625. So I'm going to say that problem is done. I think what I'll do is try to get a couple, 3 of these in one video, but I'm going to take a moment, pause this, and set up the other one. Okay, folks, I've gotten set up here to take a look at the next story problem. It says, find two numbers whose difference is 20 and whose product is a minimum. Well, for starters, let's start with, Let's start with this. Let's let x and y be the two numbers. Now, if the first one is x, second one is y, let's start with this. The difference is 20. That means that x minus y is equal to 20. And I'm going to go ahead and solve this now for y. So y is going to equal, oops, x minus 20. Reason for doing this is to get this down to one unknown. The two unknowns now are x and x minus 20. Okay, I want to make sure I solve that right. Plus, minus, yeah, it looks good. All right, now the product is a minimum, so I'm going to write out a function for the product, and it's going to be a function of just x, and the product is going to be x times y, but y is equal to x minus 20. Now, I'm even going to start graphing this while I'm working on it. This thing is going to be a quadratic that opens up because of, this is going to be a plus x squared. And the zeros of this I can see right here are here from this and 20. So this thing is likely going to look something like this, because I know that it opens up. Then the minimum value is going to occur here. We'll start looking for that value now. Now let's take this guy and distribute. Okay, start working on completing the square. Let's see, so x squared minus 20x. We'll take a look right here. Take this value, cut it in half. That would be 10. Square it. Now, if I put a plus 100 here, I either have to put plus 100 over here or minus 100 on the right-hand side. Either one is fine. This is now equal to x minus 10, the quantity squared. So the vertex of this parabola, right, x minus h, x minus 10. The vertex is at the point 10 minus 100. Okay, so it says find the two numbers. Well, we found one of them, 10. That's my value for x. The other number is now 10 minus 20, which is negative 10. So the two numbers we're looking for are 10 and negative 10. And to answer the question, well, I guess it is answered. It doesn't actually ask for what that minimum is, but this value right here is that distance is minus 100. That is the minimum value of that function. So that's probably good enough on that one. I think what I'll do is pause this while I set up the next one. All right, folks, I'm back. So we're going to look at the next application problem in your handout. So it says the height in feet of a rock thrown straight up is given by the function s of t equals minus 16t squared plus 78t, where t is in time, where t is the time in seconds. And although it doesn't say it, the s is representing the height. Now, why wouldn't they just say h for height? I don't know. Given this function here, it says find the maximum height above the ground that the rock will attain. All right, so we're talking about the height of a rock flying through the air, described by this function. Now, let me write that function over here. S of t is equal to minus 16t squared plus 78t. All right, this is the type of problem we work in physics all the time. Except in physics, we're not given the function. In physics, we talk about how to derive the equations that describe position against time. But, all right, to find the maximum, what we're going to need to do is complete the square on this. And we don't want this minus 16 there. That's going to make things a little bit troublesome. So we're going to factor the minus 16 out. Oops. Of both of these terms. Now, when you factor that 16 out of 78, how do I want to write this? Well, I guess we'll just write it minus 78 over 16, I guess. We'll just write it like that. I'll make sure I copied that down right. Yep, 78t, okay. All right. Just make sure that when you do this type of factoring, just make sure that this times this gives you this, and it does. Now we're going to do the completing the square parts, all right, being very careful. We're going to take this guy, cut it in half. That would be 78 over 32. Then you square it. let's see, a couple choices here. Why don't we put, I guess we'll just put plus 78 over 32 squared. How about we do that? And now, got to maintain equality, being careful. What we added here, we added the 78 over 32 squared, and there's a minus 16 here, times that. So over here, let's put plus 16 times 78 over 32 squared. Okay. And again, this is just some number. All right, now this thing by design is equal to t minus 78 over 32. Quantity squared. Plus whatever this is. I'll calculate a value in a moment. 78 over 32 squared. Okay, just make sure that this thing's right. So t squared gives me that. Outer inner term will give me that. And then the last term would give us plus 78 squared over 32 squared. Yep, we're good. Okay, so the this function, I did kind of a quick sketch here, noticing that it goes through 0, 0, and there's going to be some other positive time here where it goes through 0. It opens down. Oops. This function is looking something like this. We are looking for the maximum height. The vertex of this function is the point 78 over 32, right? T minus h. K, 16 times 78 over 32 squared. And let me get a value for that now. 16 times oh, come on, spit me out a decimal. All right, what I got out of this was 1521 over 16, 95 feet. So this guy right here, 95 feet. So that one was a little trickier one. The numbers were a little bit tougher to deal with, but just follow the follow the rules, follow the pattern. Take half of this, which is 78 over 32, square it. I didn't really feel like putting a putting a number there for that, because it would have made, I was going to have a hard time with figuring out what that is. So I just wrote it 78 over 32, the quantity squared, right? And then it allowed me to complete the square a little bit easier. So complete the square. There's the vertex at the point HK. Maximum value is K, and that thing is done. So 13 minutes on this video. I think I'll stop this at this point and start another one. Hope this helps. Have a great day.